Number 6 has 6 separate questions. They're all solving for x. The first one is 5x minus 7 is equal to 28. Add the 7 to both sides. So 5x is equal to 35. Divide both sides by 5. So x is equal to 7. Part B, 12 minus 5x is equal to x plus 30. So I'm going to subtract the x over to the left side, and at the same time I'm going to subtract the 12 over to the right side. Could have done it in 2 separate steps, but may as well do it in one. So the 12's cancel. Negative 5x minus x is negative 6x. X minus x gone, and 30 minus 12 is 18. Divide both sides by a negative 6. 6's cancel, leaving just x. And it's a positive 18 divided by a negative, so positive divided by a negative is negative. 18 divided by 6 is 3. For C, we have 5 times x plus 2 is equal to 1 minus 3x. And let me move this up a little bit. I'm going to distribute the 5 first, so 5x plus 10 is equal to 1 minus 3x. Let's add the 3x to both sides, and then subtract the 10 from both sides. So now I have 5x plus 3x is 8x, the 10's cancel, 1 minus 10 is a negative 9, negative 3x plus 3x are gone, divide both sides by 8, so x is equal to a negative 9 eighths. Now just a side note, so currently, before I wrote the last step, I had negative 9 with the negative in the numerator. And you can write this one of 3 ways. If there's just a single negative sign, you can put it there where it is. You can put it in the bottom if you want, or you could put it right out in front. They would all be the same thing, same value. Alright, just side note. For D, alright, we've got x plus 6. 2x minus 1 equals 0. Alright, so we need a property here. Well, if you take any 2 numbers, say a times b, and if you get 0, then either a is 0, because 0 times b is going to be 0, or b is 0, or perhaps both a and b are 0. Okay, so the point is, so you want to take each of these quantities, which are being multiplied together, and say x plus 6 is 0, or 2x minus 1 is 0. Subtract the 6 over, x equals a negative 6, add the 1 over, 2x is equal to 1, divide both sides by 2, so x is equal to 1/2. So x will be either equal to a negative 6 or 1/2. Both answers will solve the equation. So E, x squared plus 5x minus 14 equals 0. Alright, so I'm looking for 2 numbers that multiply to 14, but then add or subtract to 5. So over here, 14. Well, certainly 1 times 14 is 14, but I can't add or subtract those to get 5. However, 2 times 7. So what I'm going to do, I'm going to set up 2 sets of parentheses. Well, x times x is going to give me the x squared. 7 times 2 is going to get me the 14. Since the middle term is positive, I want to say a plus 7 and a minus 2. And then using the property as in D, I'm going to say x plus 7 is 0, or x minus 2 is 0. So subtract 7 from both sides. Over here, add 2 to both sides. So x can either equal a negative 7 or 2. Alright, but one at a time. So EF, x squared minus x minus 1 is 0. Alright, now for this, it's not going to factor neatly. You're going to need the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And that is given that you have a quadratic in the form ax squared plus bx plus c equal to 0. So just to emphasize the equation they've given us, I have 1x squared minus 1x minus 1 equals 0. So a is 1, b is negative 1, and c is also a negative 1. So following the formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative times a negative is positive, so the first quantity is just 1, plus or minus. Squaring a negative makes it positive, so 1 squared is 1. Negative 4 times 1 times negative 1. So you have a negative times a positive, which is negative, and then a negative times a negative, which actually turns this overall result for this quantity here positive. So 4 times 1 is 4, all over 2. So x is equal to 1 plus or minus the square root of 5 all over 2. Now you could write these separately. It's fine to leave it this way, but you could write it as 1 plus root 5 over 2 or 1 minus root 5 over 2. They're both valid solutions to the equation.